In this video, I will talk about the Raspberry Pi. Raspberry Pi is the crazy idea of a video game developer, David Braben, who wanted to build a small computer for less than 50 euros. Less than 50 pounds actually, since he's British. And who worked and created a foundation for this, and aimed to build a tool every student could afford, and beyond that, all the people who did not have the means to buy a computer, but were able to get their hands on old hardware, old screens, old keyboards, keeping in mind that what needed to be new and high quality was the heart of the machine, motherboard and processor. I'll show you what a Raspberry Pi is, what it can do, what it looks like, and how it is used. So when I tell you a Raspberry Pi is a computer reduced to the minimum, I do mean the minimum because it's just the contents of that small box. When you open it, what you find inside is just a board on which we will find most of the internal components you were presented in the sequence where we showed you what was inside a computer. So this is the processor, the RAM. And here we have the various communication ports. Here HDMI port, which enables to connect to any television or computer screen. A television will do just fine. That's a S-video port, also for televisions, but for older generations models. Here is the audio port on which you can plug your headset, the same one you use on your phone, and exactly the same kind of audio jack. Here, two USB ports, and here the Ethernet port, to enable network connection if need be. That's what's in the box, but to get it running, we are missing a few things to have a proper computer. So I mean a screen, a keyboard, but also power supply, a bit of memory. So what was the hard drive and what connects all this? So I'm going to FECTH all that is missing to build a computer with this. Here we are. I did my shopping and I have gathered the missing components. So I have a USB keyboard, a USB mouse going along with it. I have a screen, allowing the HDMI format, which is the format for the Raspberry. Here I have a Wi-Fi key that will enable me to connect the Raspberry to the Wi-Fi network. If I had a newer Raspberry version, I wouldn't need that key, because in the latest models, the Wi-Fi is directly built in. And I need the hard drive. I need memory space, so I retrieved this micro SD key and SD adapter, which will fit in here, into the connector at the back of the card. So before inserting this card into the Raspberry, there was a small task to perform. I mean that to get the Raspberry running, we need an operating system. The recommended operating system for this machine is Linux, a Debian version, and you have to retrieve that operating system and install it directly in the memory to be able to use the Raspberry. There are pre-installed micro SDs. If you don't know how to do it, if you do, retrieve the software if you have another system on the internet, and install it on the card. It is quite easy to do, and the matter is well documented and available on the Raspberry website. Then, I am going to plug in the various USB devices. And at that moment I realized that I have 3 USB devices, but I only have 2 USB ports. So again, if I had a newer Raspberry version, I would have 4 USB ports, but since it's not the case, I am going to use a USB multi-plug, which has another advantage. The plugs are electrically powered. Well, to have a keyboard running, that's not very important, but regarding the Wi-Fi key and the mouse, that saves power for the Raspberry, because it can lack power to charge the USB devices. I plug the key, the keyboard, the mouse, without forgetting anything. Here I have the screen, but it is not connected. You have to plug it into the HDMI port. Now that everything is plugged into the USB hub, I connect it to the USB port. All I need now is the power supply. Here is a small 3 volts external power supply. I can connect it, that will trigger the Raspberry startup automatically. There you are, it should start now. So with this Raspberry Pi we managed to start. We find ourselves in a classical Linux working environment. We have access to a wide range of tools we always find in other computers. For example, we have an Internet Navigator. We have a text editor. We have classical code editing tools. We should also mention the two languages are included in this package. One development environment is the Python language. The other is the Wolfram language, better known as Mathematica, that enables to do a wide range of calculations and graphical manipulations, amongst others. But what's more, that we don't find in a classical computer, but that we do find in the Raspberry Pi, is that we have access to something I have not showed you until now. So I will show it to you now. I'm talking about that part, the connectors. These connectors are called GPIOs, for general ports for input and output. Those are small logical connectors, on which you can read or write signals. Through the languages, particularly Mathematica and Python, we are going to be able to read what's in these connectors and to write on these connectors. And so we will be able to connect to objects, electronic cards, to sensors. And we are going to be able to use those informations and activate other objects with the calculations we've made on these informations. To illustrate how we can use these GPIO connectors, we have retrieved a small robotic arm, which is a toy, that we sacrificed for this occasion. We transformed its remote controller into a small electronic patch-up, so that the orders will be given simply by sending signals, right, left, up, down, with 4 of the wires that are plugged into these connectors. The others are unplugged. There you go, demonstration. So we have some code here. That's Wolfram language. A bit of code that sets up the orders we send to these connectors, and I gathered all this into some small buttons, so demonstration. So up, down, to the right at the same time. We stop it. Going back to the left, the batteries that make it go left are a bit more tired, but we can still go to the left and up at the same time. So here's what we can do with the output-input direct control ports of the Raspberry Pi.